Welcome Year 9s, carrying on with trigonometry today. We are going to focus in this video on 3D trigonometry, and this is pretty much using the same kind of information that we've used as we've looked at right angle trigonometry. It's just applying that in a 3D situation. But before I do begin that, I just want to talk about a couple of things that you will need to know about maybe for one of the questions that I'm going to get you to do today, and it's called angles of elevation. So angle of elevation, and the other is an angle of depression. Okay, elevation, let's talk about that first. Let's say you've got a tower over here, or a basketball, let's say it's a basketball hoop, right? And you've got a dude, there's a dude, right? He's lying on the ground for some reason. Okay, I'm not good at drawing, as you can see. There's my dude. Okay, and let's say we wanted to know the angle of elevation from the dude to the top of the basketball hoop. Well, what we would do is we'd draw a direct line from dude to basketball hoop. We've got a horizontal ground level here, and this would be our angle of elevation there. We'll call it theta in this case. So that's an angle of elevation. Now, let's talk about an angle of depression. Okay, this is not a sad angle. Now, with an angle of depression, let's draw another diagram. Let's say we have a tower. Here's our tower. Right, or castle sort of thing, right? Here's our, right, and there's a dude up on the battlements, right? There he is, looking at an enemy who's lying in the grass trying to be sneaky or something, right? Here he is. Okay, an angle of depression. So he's looking down, there's his eye, right? So we look down to the dude lying in the grass, right? And then we draw a horizontal line across from where that man's eye is, and this here would be our angle of depression. The angle from the horizontal to the line that connects up the man's eye with the dude lying in the grass. Okay, that would be angle of depression here. So that bit there, in that case, theta. Okay, so I hope that gives you just a little introduction to what an angle of elevation and an angle of depression is. I think you're just going to need angle of elevation for one of the questions that I'm doing with you. And don't get too concerned if you get stuck on this, because we will be going over this in IGCSE when we start that next year. This is just, you're getting a bit of extra because we've already finished our Secondary 1 course. Okay, so here I have in question 1 a rectangular box, and I've got to find AC. So here's A. Maybe we'll do a better colour. Here's A, and here's C. So AC is the length between A and C. So what you can do is you can just draw a line between them. Now what you should notice is that you've got a triangle, ABC, and that this angle here at B is a 90-degree angle, since the bottom of the rectangular box is a rectangle, right? Rectangles have 90-degree angles. So I'm just going to quickly draw a sketch of this. This is A, that bit there. This is C, that bit there. This is B with my 90-degree angle, that bit there. And I know that this length is 12 and this length is 5, and I've got to find length of AC. At this point, all you geniuses there are probably thinking to yourself, well, I hope you are at least, Pythagoras Theorem. And that's exactly what we'd do. So we'd go AC squared equals 12 squared plus 5 squared, right? Because this is our hypotenuse here, isn't it? Okay? So then we can find that AC squared is equal to 144 plus 25, which means that AC is equal to, what's that, 169 AC squared, and the AC is equal to the square root of 169, which is equal to 13. So AC is equal to 13. Now we're going to find angle AR. So I'm going to use a different color here. Here we go. We're going from A to R. So I just join them up, and I look for a right angled triangle, and here's my right angled triangle. Okay, I've got a right angle there between that CR line and the base of the rectangle, because you know in a box the edge of the box is at right angles to the flat surface on the bottom, isn't it? Okay, so for part B, I'm going to draw my triangle and label my sides. It's always good to draw your triangle. Now what do we know? This is R and this is C, and I know that that's 4 because it tells me so on the diagram. And here's A. Do I know anything else? Well, yes I do. I have just worked out what length AC is in the previous question. It's 13. And now I can again use Pythagoras Theorem. AR squared, which is the hypotenuse, should be equal to 13 squared plus 4 squared. And what is 13 squared is 169 plus 16. So that is AR squared. And then we're going to need to add those two together. So what do we get there is 185. So AR squared equals 185. And we want to take the square root of that. What does that give us? It gives us 13.6 centimeters. Now the last thing that I have to find is the angle between AC and AR. So AC is the green line that we did in the first one, and AR is this length that we've just found here. So the angle between them is this angle here. Okay, that angle there, which is this angle here on our diagram. So we could use right-angled triangle trigonometry here. We've got an opposite and we've got an adjacent, because this is our hypotenuse. So opposite adjacent is OA or TOA, so it's tan, and we'll call this angle that we don't know, let's be imaginative and call it theta, is equal to opposite, which is 4, over the adjacent, which is 13. And so theta, what do we do to get that tan across to the other side? We do the inverse tan of both sides. So we end up with theta is equal to 4 over 13. And so theta is equal to, I'm getting 17.1 degrees. Okay, so that's our first question. Let's move on to another one. This is number 4. And then I've got 11. Yeah, I'll just do 3. Okay, so we've got a square-based pyramid and we need to find AC. So I'll just draw this. I'm going to use the right-angled triangle ABC. So AC squared equals, and you can see we've got a right angle here, can't we? So is equal to, and so AC is the hypotenuse. So AC squared is equal to 200. So AC is equal to the square root of 200. And if we wanted to, we could make that to 3 significant figures, which is 14.1. Obviously, this here is your more accurate answer, but they might ask you to write it in 3 significant figures. The height of the pyramid. Okay, how do we find the height of the pyramid? Well, we can use this triangle here. AV in the bottom there. Let's just call that M, because it's the midpoint of AC. So for B, the height of the pyramid, we've got a triangle that looks like this. What do we know about it? Well, we know that if this is A and this is V and this is M, we know that AV is 20, right? It's one of those sides, and the VC is 20, so that means AV is also 20. And we know what AM is, because M is the midpoint of AC, and we found out the length of AC to be square root 200 here. So this is half of square root 200, and I'm writing square root 200, half of square root 200 because I want to be accurate. This has already been rounded, so I want to use the most accurate information I can, which is half of square root 200. And therefore to find Vm, we're going to use Pythagoras Theorem. So we could go AV squared, which we know is equal to AM squared plus VM squared. Now, that means 20 squared equals, now we've got to put this all in brackets because we're squaring the whole thing. So we get 400. Now, when you do this, make sure you put it in the brackets. Half of square root 200, close the bracket, make sure that you don't have your, so when you put the square root 200 in, use the cursor movement to the right so that you don't end up with the square root going across your bracket. So when you square that, you should get 50. Okay, if you haven't got a 50 when you do that, press the bracket, start again by pressing the bracket, go 1/2, and then use the cursor to go up to the middle again, square root 200, then use the cursor to the right button, and then press the bracket button, and then press the square button, and you should get an answer of 50. Okay, plus Vm squared, and then we rearrange that. So I'm going to bring that 50 across to the other side. So I should get 350, because I'm subtracting it, should be equal to Vm squared. And so Vm is equal to the square root of 350. And if I wanted to, I could just type that into my calculator, and I get 18.7. Okay. We're going to move on to C. The angle between VC and the base. Okay. Well, the angle is exactly the same as this angle here, right? That angle there, those are the same. So we can actually just use the triangle that we've already done. But just so that you don't get freaked out, I will use this. Now, we know this is V, this is the midpoint M, this is C. I want to know this angle here. I know that this is 20, and I know that MC is half of square root 200. So if I want to know theta there, I've got, let's label our sides. This is a hypotenuse, and this is an adjacent. So, so that's ka, isn't it? So we'll go cosine theta equals, now what goes over what? Adjacent, so that's that, over hypotenuse, which is that. And then to get the theta by itself, we say theta is equal to the inverse cosine, and it will open up a bracket for you when you do shift cosine. And then we pop that in here, put a bracket at the end, and let's see what we get. So shift cosine, put in your fraction. You could just do 0.5 times square root 200 on the top, just to make it easier, over 20. Now when I chuck this in, I'm getting 69.3 degrees. The angle AVB. Okay, we'll try that now. AVB. Angle AVB. Okay, so for angle AVB, we've got a different triangle altogether here, don't we? So let's just have a look at that. This is the triangle we've got here. Okay, and we want this angle here. Now, the way we could do this is we could potentially split this triangle. There's going to be a few steps involved in this, because you can see that this is not a right angle triangle. That angle is not a right angle there. So what I would probably do at this point is split the triangle down the middle like this, and then we'll have a right angle here and a right angle here. Okay, so I'm going to do that. A, V, B, and I split it down the middle like this to create two. Oh, that looks absolutely horrific. To make two equal triangles. Now, what do we know about this? Well, we know that VA is 20, and we know that half of AB is 5. And so then we can work out this middle line here, this one here, which I made a bit of a hash up of, using Pythagoras. So again, this is our hypotenuse. So we're going to go 20 squared equals 5 squared plus, and we'll call this x squared. You know what? I'm just having another thought, chaps and chappesses. We don't need to do that. Okay, Mr. K is making more work for himself. And remember, in maths, we are efficient. Okay, we use efficient means. So yes, I like the idea of having this line down here, but we just want to find this whole angle here, right? That's what we want to find. So if we want to find that angle there, we could find this angle using right-angled trigonometry, and then we could double it, because this is exactly the same here. So let's focus on this, and I'll put another letter here, I'll put Y. So let's focus on AVY, and as I've put already, this is a hypotenuse, so that's hypotenuse there, which is looking very messy. So that's hypotenuse. And this number here, 5, is our opposite, because this is theta, right? This is our opposite. So opposite and hypotenuse is sine, so I'm going to go sine theta is equal to the opposite, which is 5, over the adjacent, which is 20. And so theta is going to be equal to the inverse sine of 5 over 20, which happens to be 1/4, but I'll just leave it like that. And we chuck this into our calculators, and what do we get? I'm getting 14.5 degrees to 1 decimal place, or 3 significant figures. And that's that one. Now, if we want therefore, so I'd write therefore, angle, that's the sign for angle, AVB is double that. So I'm just going to times the unrounded number on my calculator. And when I double it, I get 28.95. So it's actually going to be, if I round it to the 1 decimal place, it should be 29.0 degrees. Okay, moving on, we have the angle. We're trying to find angle AVC. AVC. Okay, right. I'm going to clear a bit of space. How am I going to do this? Okay, let's clear that. Okay, AVC. So we'll do this in red. Okay, this is AVC. Again, it's not a right-angled triangle, but we do know angle, we can find out angle AV, and remember that was M in there. So let's focus on that. We've got, oops, running out of room here. I'm just going to move some stuff around. Didn't realize this would take so much room. Okay, we can use the triangle that we did here to help us find angle AVM. Okay, so let's do that now. This is probably E, isn't it? Okay. AVM. So we want to find that angle there. We know this and we know this. So we know a hypotenuse and an opposite. So it's sine again. Sine theta, or unknown, equals opposite, which is 0.5 times square root 200. And should be all over the 20. And then we get theta is equal to 0.5 times square root of 2, the inverse sine of that. Oh, what am I doing? 0.5 over square root 200, all over 20. Now, if we chuck that into our calculators, what do we get? 0.5 times square root 200, all over 20. Put our bracket in. Good practice. I'm getting 20.7 degrees. To 1 decimal point. Now, if that's this angle here, and we want this whole thing here, you can see that that's double. So I'm just going to go, therefore, angle, what is the angle called? AVC. AVC equals, now I double my unrounded answer and I'm getting 41.4 degrees. And that would be that one. So I hope that's making sense so far. I'm going to do one more for you, and this is a triangular pyramid on a horizontal base. What do we know here? We know that V is vertically above B, and we know that this is 10. And we know that ABC is 90 degrees. Okay, that's 90 degrees. Doesn't look like it, but apparently it is. And we know that AB equals BC. Okay, and they're both 15. That's 15 there. And I've got to calculate the size. Oh, and this is a midpoint, okay. And we've got to calculate the size of VMB. So we want to know this here. Okay. Right, where are we going to start here? Well, let's see. I think we need to know, just thinking if there's an easier way of doing this. We need to know length MB, okay? Because remember when we talked about trigonometry before, if you want to know an angle, then you need two sides. Well, we've got this side here, so if we also knew this side of the right angle triangle, see this is the right angle triangle that we're going to use to find that angle, we need to know one other side, and I think that finding this length here would be easiest. Okay, so that's going to be my strategy, is to find that side. And so I'm going to probably try to use a bit of Pythagoras to do so. Now, I'm going to first of all find AC. Now, AC is my hypotenuse of triangle ABC, right? So we're working with this triangle here first. Okay, so AC squared should be equal to AB squared, which is 15 squared, plus BC squared, which is 15 squared. And so we should get AC squared is equal to 15 squared, that's 225. We double that, 450. And therefore, we know that AC is equal to square root 450. And I'm just going to leave it as an accurate number at that point. I'm not going to do anything else with it because we want as much accuracy as possible, and that's very accurate. It's exact. Okay, now, therefore, we can say that AM is equal to 1/2 of the square root 450. Okay, so that's there. Now we're going to look at this triangle here. Okay, ABM. So triangle ABM. So you've got to be a bit of a sleuth sometimes. And here's triangle ABM. Where is the right angle? Well, the right angle is at M. How can we tell that? Well, if we look at the original why is this not working? For some reason OneNote stops allowing me to delete things sometimes. Okay. Okay, well that's a 15 there. We know that this is a right angle. When we split this in half and we've got a midpoint, that means we've got a 45-degree angle here. We already knew that this was a 45-degree angle and this was 45 because AB and BC are equal, and if ABC is 90 degrees, that means these are 45-degree angles. And that means that when we do a midpoint here, we're going to get a 90-degree angle. So this is 90 degrees here. That is 45. So we've got another right angle triangle. We know 45 and we know 45 here. This is A, This is ABM. And so I want to find length MB. Now, what else do I know? I know AB is 15. And it looks like I probably didn't need to... What a wally. It looks like I didn't actually need to do that first step. Okay, but never mind. This often happens to me. I'm working away and I realize, oh, that was dumb. I shouldn't have done that. Never mind. We can still get on with it. Okay, so I want to find this. I'll call it X. And I know that this is 45 degrees here. Well, you should be able to think quite carefully about this. Okay, so we've got a hypotenuse, and we've got an opposite, and we've got 45 degrees. So this is, that's an H. This is therefore sine. So we go sine 45 is equal to opposite over 15, and we want to find the opposite, so x is equal to 15 sine 45. Okay, what does that look like? 15 times sine 45, and that's giving me an answer of x is equal to 10.6 degrees. That's just to one decimal place. I would suggest saving your unrounded number in your calculator so we can be accurate. Now, we come to the last step. We now know this. We know this, and we want to know this. So let's draw up that triangle. This is the angle that we want to know. We know that this is 10, and we've just found this to be 10.6 something. So label the triangle. Okay, what are we doing here? Okay, this is our hypotenuse, this is our opposite, and this is our adjacent. So you can see we're using O and A, so it's tan. Tan theta is equal to opposite, which is 10, over adjacent, which is 10.6. And so theta is equal to the inverse tan of that. Now, what does that give us? Inverse tan of 10 over answer. 43.3 degrees is what I'm getting there. Now, I hope that's correct. I hope I haven't made any errors along the way. Alright team, that gives you a little bit of an idea of what you're going to need to do as you go through this exercise. I'm not getting you to do all of them. And again, if you are getting stuck on any of this, just let me know on my Gmail account, Mr. K account, the one connected to the YouTube. And I can either do a video for you or just show you my working. Alright team, God bless. Have a good holiday too. I think this is our last math lesson of the year.